Welcome back everyone, Patrick here, and in this next video, and actually over the next couple of videos, what we're going to discuss is how to find the shortest distance between a line, in this case it's 3x plus 2, and then a point, 4 and 3. So we're going to start off with an example here, but we're going to do a bunch of examples because these kinds of questions, they're very popular and they can be presented in different formats. So in this case, we're given the equation of the line, we're given the point, but that's not always what's going to be given to you. So we're going to do a couple of videos with these types of examples. Now, there's actually two ways to do this. The first way, which is going to be the longer way, and the way that you're probably going to be expected to show and know how to do, that's the way I'm going to show you to do first, but there's actually also a shorter way to do it. It's actually with a formula that you're going to have to memorize. It's from a higher level course dealing with vectors in a higher grade, but it's a formula that you could apply to these kinds of questions. And it's just a nice quick way to check your answer. You're probably not going to be allowed to use the formula on a test. You're going to have to show your work. But if you do get the time on the test, it's going to be a nice quick way to potentially check your answer. So I'm going to go over that formula at the end of this video. I'm first going to show you the more common, the longer way, and the way that you're probably going to be expected to know how to do. Now, before getting into this specific example, I want to write out the intuitive steps that we're going to go through. So let's say that we have this line over here. In this case, it's 3x plus 2, but let's keep it general for this overview. Let's call it L1. Right, so we have this line L1, and then we're going to be given a point. Let's call this point M. In this case, it's 4 and 3, but for these general steps, we'll call it M. Now, this line here, again, I mentioned it's going to be given in different formats, these questions. So sometimes you'll be given the equation of the line, right? In this case, we're given the equation of the line, but then this equation can be in different formats. Here it's in y equals mx plus b format. Sometimes it's going to be in standard form. Sometimes you're not going to be given this equation. You're maybe going to be given points, maybe 2 points on the line. So first you'll have to find the equation of the line, get it to this point, and then follow these steps. So when I'm going to go through these steps, these general steps here, I'm assuming that you're already at the point where you have the equation of the line, which is this L1 over here. So the question is, how do we find the shortest distance between a line and a point? If you notice, there's actually an infinite amount of distances from this point to this line, right? We can have like a distance from here to here, or from here to here, right? All the way here. We can have a distance here, right? There's an infinite amount of distances, but there's only one shortest distance. And if you think about it, if you look at the diagram, the shortest distance is always going to be the perpendicular distance from the point to the line. So what that means is that the distance, this line here that we have, it makes a 90-degree angle with this line that we're working with, this line L1 over here. That's always going to be the shortest distance, because if you think about it, all the other distances, which are longer than this one, the angle between the line and this line, this distance line, it's not going to be 90 degrees. Okay, so the shortest distance is always the line, the distance line is always going to be perpendicular or make a right angle or an angle of 90 degrees with the line that you are working with. So that's the first thing I want to point out. So what are the steps here? How would we find this distance? Well, the first thing we got to do is we actually have to find the equation of this line over here. So we're going to have to find the equation of this line. Let's call this line L2. And then we're going to have to find the point of intersection between this line L2, and then this line that we're working with, L1, the line that we're given, and that's going to be over here. So we'll call this point N, and then once we have this point N, which is the point of intersection between these two lines, we can find the distance between M and N, and that's going to be the shortest distance. So writing this out in more technical, specific steps, the first step would be finding the slope of, finding slope of L1 of this line over here, right? The line that you're either given or you're going to have to find, as we're going to do in future videos. So we find the slope of L1, and then what we do is we'll have the slope here. Well, what's the slope of this line going to be of L2? Well, it's going to be the negative reciprocal of this slope, right? Because these two lines are perpendicular to each other. So the second step is going to be to find the perpendicular slope of L1. So once we have the slope of L1, we just take the negative reciprocal of it to find this slope, this perpendicular slope. And then once we have this slope of this line, we have a point on the line, which is the point that we're given in the question. So we labeled it point M. So then we're going to have to find the equation of L2, this line over here, using that perpendicular slope that we found in step 2 and the point N. Right? We have a point, a slope, we can find the equation of this line. That's going to give us the line of L2. And then once we have the equation of L2, we find the point of intersection, which in this diagram we're labeling as point N, between the two lines L1 and L2. Right, that's going to be the fourth step. And then the fifth step is we find the distance between M and N. And that's going to give us the shortest distance. So find distance between M and N, like that. Okay, so these steps, again, they're the steps we're going to follow. And these steps assume that you have the equation of L1 and you have the point. But a lot of times you're going to have to find this equation first. So there may be some preliminary steps. We're going to go over examples after this video where we're not given this equation, L1. We're first going to have to find it, and then we're going to follow these same steps. But in general, this is what we're going to be doing. And again, this is the longer way. This is the way that you are probably going to be expected to show on a test. But again, at the end, I'm going to show you a quick formula that you can use to check your answer. So let's go through these steps over here. So step 1, we have to find the slope of L1. And it's nice because it's already in y equals mx plus b form here. So the slope of L1 is going to be 3. Second step, we find the perpendicular slope of L1, which is going to be the negative reciprocal of this. So this is like 3 over 1. So the negative reciprocal of this, we would flip it. It's going to be 1 over 3, and then we add a negative. So it would be negative 1 over 3. Right? We just changed the sign. If this was negative 3, this would end up being positive 1 over 3. But in this case, that's going to be the perpendicular slope right there. And then the third step is we have to find the equation of L2 of that perpendicular line that has this slope and is going through this point, 4, and 3. So the way we would do that is we would first plug in the slope. This is the way that I do it to find this b value. You could also use that formula. I personally don't like to use it this way, but if you do use this, just make sure that you're getting the same equation that I'm getting at the end. So finding this b value, what we got to do is plug in 3 for y, and then we're going to plug in 4 for x. Okay, so we'd end up with 3 equals negative 4 over 3 plus b. And so I'm going to erase these steps here. So basically we'll have 3 plus 4 over 3 is equal to b, this b value. So, give me a sec here. Yeah, so from here, we just add these. So this would be 3 over 1. Common denominator between 1 and 3 is 3. So multiply this by 3, multiply this by 3. So we'd have 9 over 3 plus 4 over 3, which gives us 13 over 3. And then that doesn't simplify any further. So our final equation of L2 of that perpendicular line, is going to be y equals negative 1 over 3x plus 13 over 3, like that. So from here, what we do is, what was step 4? We got to find the point of intersection between L2, which is this line, and L1, this line that we were given. So finding the point of intersection between them, you could do substitution, you could do elimination. What I'm going to do, notice that the y's are isolated, so I'm going to take this expression for y and then just plug it in here. So we'll have 3x plus 2 equals negative 1 over 3x plus 13 over 3. So from here, I'm going to bring this over, so I'll have 3x plus 1 over 3x equals 13 over 3 minus 2. Right? We got to solve for the x value. So bring all of the expressions that have an x to one side, bring the numbers to the other side. So from here, let's do this on this side, 3 plus 1 over 3. It's like 3 over 1, multiply this by 3, multiply this by 3 for the common denominator. 9 over 3 plus 1 over 3 gives us 10 over 3. So this ends up being 10 over 3x. And then we'll have 13 over 3 minus 2, which is like over 1. Common denominator, 3, 3. 13 over 3 minus 6 over 3, which gives us 7 over 3. So we'd end up with 7 over 3 right there. Now from this point, multiple ways to solve for this x value. We could just divide both sides by 10 over 3. Right? So x would end up equaling, these would cancel out, it would end up equaling 7 over 3 divided by 10 over 3, which would be like 7 over 3 multiplied by 3 over 10, which would give us 7 over 10, like that. Another way to do this from here, you can actually put these as one fraction, so you could say 10x over 3 equals 7 over 3. Whenever you have one fraction on each side, you could then cross multiply. So we'd have 30x equals 21, right, cross multiplying. Then we'll have x equals 21 over 30, which we can divide the numerator and denominator by 3, simplifies to 7 over 10. So whichever way you do it, x equals 7 over 10. So that's the x value where this line and this line are going to intersect that point n that I showed you on that general diagram. And then from here, we got to find the y value, the corresponding y value. You could take that x value, You could plug it in here, or you could plug it in here. The y value should be the same for both. I'm going to plug it into this one. So we'll have y equals 3 bracket 7 over 10 plus 2. It's like 3 over 1. 3 times 7, 21. 1 times 10 is 10. Plus 2, this is going to be like over 1. 21 over 10. Common denominator between 1 and 10 is 10. So multiply this by 10, multiply this by 10. And we end up with 41 over 10, like that. So this ends up being 41 over 10. Now, be careful here. Keep these as fractions. Unless your teacher allows you to work with decimals, a lot of times for questions like this, you're going to see solutions given in exact values. There's going to be like a square root. I think the answer to this, if I remember correctly, is going to be 11 over root 10, but we'll confirm once we finish the question. But a lot of times you're going to see the solutions in this format. They won't be given in decimals. Now, your teacher may allow you to work in decimals, but some teachers may expect you to get to this point right here. And so to get to this point, you can't be converting these fractions to decimals yet. You got to work with the fractions the whole time. So it's tougher, there's more algebra, but just in case, you got to get to this kind of format. These are the formats you'll most likely see at the back of your textbook as well. So the way they get to these formats is using the algebra that we're going through here. So you got to be really careful with your steps. So finally, the fifth step, so we have the point of intersection between those two lines, point N, and we have point M. And now to find the shortest distance, we just have to find the distance between those. So that's using the length formula. Length formula is square root of x2 minus x1 squared plus y2 minus y1 squared, like that. So let's label these. I'm going to label this x1, y1, x2, y2. Again, it doesn't matter. You could let this be x2, y2, that x1, y1. You'd get the exact same distance in the end. So from here, now here's where you got to be careful with your algebra because there's going to be lots of fractions. So we're going to have x2, which is 4, minus x1, which is 7 over 10. And then that's going to be squared. Plus y2, which is 3. Give me a sec here. 3 minus 41 over 10, which is y1. And then that's going to be squared, like that. Now, in this particular case, what I recommend is doing the algebra for both of these on the side, just so it doesn't get too messy over here. I feel like it's going to minimize the risk of making a mistake. So let's do 4 minus 7 over 10 over here. So this 4 is like over 1. Multiply this by 10, multiply this by 10. So we'd have 40 over 10 minus 7 over 10, which gives us 33 over 10, like that. So this bracket here is going to be 33 over 10, but that's still going to be squared. Don't forget about the exponent there. And then we're going to have 3 minus 41 over 10. So this 3 is going to be like over 1. Common denominator between 1 and 10 is 10. So 10. 10. 30 over 10 minus 41 over 10 would give us negative 11 over 10. So this bracket simplifies to negative 11 over 10. That's going to be to the power of 2. So now from here, whenever you have, just as a quick review, an exponent, or a fraction rather, to an exponent, well, you could take that numerator to the exponent, you could take that denominator to that exponent. So that's what we have to do over here. So following that rule, 33 over 10 to the power of 2 would be 33 to the power 2 over 10 to the power 2. 33 to the power 2 would give us 1089. 10 to the power 2 would give us 100. So that's what this is going to simplify to. So let's continue this up here. So we'll have the square root of 1089 over 100. That's what this is going to be. And then following the same process for this, negative 11 over 10 to the power 2 would be like negative 11 in brackets to the power 2 over 10 to the power 2. Negative 11 to the power 2 would give us 121. 10 to the power 2 would give us 100. So we'd end up with, this is plus 121 over 100, which is nice. Notice we have a common denominator there. We don't have to worry about finding that. And when we add these, we would end up with, in the numerator, we'd end up with 1,210 over 100, like that. That's what the value is going to be. Now from here, you can actually simplify that fraction. Notice zeros would cancel out, or you could divide the numerator by 10, the denominator by 10, and you'd end up with the square root of 121 over 10. Now from here, you can't simplify this fraction anymore, but what you can do at this point, just to bring back a rule, if you have the square root of a fraction, what you can do, similar to that exponent rule that I showed you, you could take the square root of the numerator over the square root of the denominator. Right? This is a rule that you can apply. So from here, it's a nice rule to apply in this case because notice that the square root of 121 is actually going to be a smooth number. Root 10 isn't going to be a smooth number, but root 121, that's 11. And so we end up with 11 over root 10. Right? As I mentioned before, that's what the answer was going to be. Okay, so these are the steps that you follow to get an answer in that format. A lot of times you're going to see textbooks give answers in this format, and a lot of times your teacher's going to expect you to be able to get to this point over here. If they expect you to work with decimals, or if they allow you to work with decimals, then yeah, things are going to be a lot easier. You don't have to worry about all this algebra. You could plug in decimals. You could just skip a lot of steps if you're working with decimals. And then if you get a decimal value and then the answer in the back of the textbook is in this format, you could just find the decimal value of that and compare it to yours. Make sure that they're the same. Okay, but if you do have to get to this kind of format, that's the way you do it. So 11 over root 10 is the final answer to this question. Okay, so that's the long way to do it. That's the way that we're going to be doing it over the next couple of videos. Now, what's the short way? I promised you that there's going to be a short way to do this. There's actually a formula. So let me actually just write the answer and see if we get the exact same thing using this formula. It's kind of cool how it works out. So the first thing you got to make sure is that the line that you're working with, it's going to be in standard form. So if you remember, standard form is ax plus by plus c is equal to 0. Right? That's the standard form. And if you have a line and then you have a point, let's call it mn. That's the coordinates of it. In this case, it's 4 and 3, but I'm first giving you the general formula. So let's say that this is what you're given. You're given the line, you're given the point. Well, the shortest distance is going to equal the absolute value, I'm going to explain what that means in a sec, of this a value times this m value, the x value, the point that you're working with, plus the b value times the y value, the point that you're working with, plus c all over the square root of a squared plus b squared. So this formula here, as long as that line, it's in standard form, between this line and this point, this formula will always give you the shortest distance, which is a nice way to check your answer. It's a formula you're going to have to memorize, but again, it's a quick way, not even the quickest way, because you do have to make sure you convert this line to this format, etc., and there is some algebra over here, but it's a much quicker way than that first way that we did. So it's just a nice way to check your answer. So first thing I want to actually talk about is this absolute value. So this is a concept you're going to learn in higher grades, but basically what absolute value means is it makes sure that whatever's here ends up being positive. So let's say we have the absolute value of positive 5. That's just going to give us positive 5 because it's already positive. So the absolute of any positive value, it's just going to be that value itself. But let's say we had negative 5, the absolute value of negative 5, well, it changes that negative to a positive. Right? So any positive keeps it as a positive, any negative changes it to a positive, and then those absolute value signs go away. And then the absolute value of 0 is just 0. Right? That's basically what the absolute value signs do. They change any negative to a positive, any positive they keep as a positive. So how can we check this formula with what we're given? Well, first off, the line y equals 3x plus 2, notice that that's not in standard form. In order for it to be in standard form, everything has to be on one side. So let's bring the y over, and we'll have 3x minus y plus 2. Right? This positive y becomes a minus y. And then we have the plus 2 at the end. So from here, we have it in ax plus by plus c format. So notice that the a value is 3. The b value is negative 1. That's what's in front of the y. And then the c value is 2. And then the point that we're working with is 4 and 3, which is this m and n. So in this case, the m is 4, the x value of the point, the n, which is the y value of the point, is 3. So we have these parameters, and then watch what happens when we plug it in here. We'd end up with the absolute value of 3, the a value, times the m value, 4, plus the b value of negative 1, times the n value, which is 3, plus the c value of 2. That's going to be all over the square root of a squared, which is 3 squared, plus b squared, which is negative 1 squared. So what happens when we simplify all of this? Well, we'd end up with the absolute value of 12, 4 times 3. Negative 1 times 3 is negative 3, right? And then plus negative 3 is the same as minus 3. And then we have plus 2 all over the square root. 3 to the power 2, 9. Negative 1 to the power 2 is 1. And so we'd end up with 12 minus 3, which is 9, plus 2, which is 11. The absolute value of 11 is just 11. If we got a negative 11 here, then the absolute value of negative 11, we would just put a positive 11 over here. But in this case, it was already positive. The absolute value of a positive is just that positive value over the square root of 10. Notice how it's the exact same distance that we got when we did it the longer way. Right? So Your teacher may show you this, may not, but thought I would show it to you just in case you want to check your answers. If you get the time on a test to check your answers, it's a nice way to give you some confidence to make sure that you got the correct answer, or that you need to go back and check your algebra, that you didn't get the correct answer. Maybe if it's a multiple choice question, a quick way to do it as well. So either way, I thought it was beneficial that I would show you this. But again, you're going to be most likely expected to know how to do it the longer way, which is what we went through.